This is 3/7's homework assignment in the textbook. We are looking at inequalities. We're going to not only solve them, but graph them, which is just on a number line, and then check the inequality, and that's going to require 2 checks for these. One for the actual value, the number that we're going to use as our boundary point, but then also for our less than or greater than, do we have it go in the right direction? Because you could have the right number, like x is greater than 2, but it shouldn't be greater than, it should be less than. So 2 checks on all of those. So starting on number 3, we have 3x plus 4 less than 19. We're going to treat these just like an equation. This is our dividing line. We're trying to isolate the variable. So here's x. Same procedure. We're going to get rid of the number that is not attached to a variable first. So we're going to minus 4 from both sides. That will leave me 3x less than 15. And again, we want to get rid of this. This is multiplication, and we're going to divide. Now, this is the step with an inequality where things can change. If this number that we were dividing by was a negative, we would have to flip this inequality. But it's a positive, so nothing's going to change. So keep the x on the left side. Keep this less than. And then my answer here is 5. So I have solved the inequality. Now I'm going to graph it. Real quick and easy. Here's 0. Here's 5. X is less than 5. First of all, there's no equals, so this will be an open circle, so I can put it right there. This is called our boundary point. And if it's less than 5, the answers are everything this direction to negative infinity, everything less than 5. Okay, so you're shading the solution set, the answers. So x represents the solution set, is every number less than 5, all of these numbers. Okay, we got 2 checks to do. Check 1, old-fashioned check like we've been doing for an equation, and we actually make it an equation. So 3x plus 4 equals 19, and we're going to plug in our number of 5. So 3 times 5 plus 4 equals 19. 15 plus 4. Sure enough. I know that 5 is right, but what if my solution set is actually the opposite, all of this? So for check 2, we go back to the original, and we actually use the inequality because that's what we're testing here. Testing the inequality, and we're going to choose a number that's in the solution set. So look at my shaded region. It's nice when you have a graph, you can just look at it, or just think any number less than 5. If 0 is available, you probably should use 0. It's super easy to work with, but it's not always in the solution set, so don't fall in love with it where you think you can use it every single time. It is in our solution set here, though, so I'm going to go ahead and use 0. Makes my life nice and easy. 0 plus 4. Now, when you get to here, you can't just say, okay, I'm done with my check. You have to make sure this makes sense. The whole point of the check is this equal? Yes. Is this true? Is 4 less than 19? Yes, it is. So I know this is pointing in the right direction. If this said 4 is greater than 19, then something's wrong. Okay, this is going the wrong direction. This should have been flipped, or we flipped it and it didn't need to be flipped. Something along those lines. So check number 2 is going to tell you if your less than or greater than is pointed the right direction. Number 4. Okay, the variable's on the right side here, so we're going to eliminate everything from the right side, starting with the 10. We're going to minus 10. Still have 4b, and we get negative 4. And then divide by 4. Now, the number we are dividing by is positive. I know there's a negative here, but the number we're dividing by is positive. So this is not going to change. So keep b on the right side and keep this facing the same direction. And now I get negative 1. So we dealt with negatives, but we did not flip because the number we divided by was positive. If you want to rewrite this with b on the other side, you can, but you need to keep this consistent. Okay, this is open towards the b, so it needs to be open towards the b. These both say the same thing. Both of these are acceptable. If you like the variable on the left side, that's fine. It doesn't have to be, though. Now, let's say you didn't change it around. When you read this, you still read it from the variable. So you say b is, and then you look, is it open towards the variable or closed towards the variable? Okay, it's open, so it's greater than. Where this one, if you just look at this, b is greater than negative 1. That makes sense. Okay, but a lot of times students will look at this and be like, well, this says less than, but you're reading it from the variable. Negative 1 is less than b, but if you're reading it from b, b is greater than -1. So these inequalities can be read both directions. So we can't just memorize this says less than, this says greater than. It depends on which direction you're reading it. So if it's open towards the variable, it's greater than. If it's closed towards the variable, it's less than. So quick graph, here's 0, here's -1. Now, it is included, so my boundary point is going to be filled in. And again, it says greater than. All the numbers, the solution set is all the numbers greater than -1. And the numbers that are greater than -1 are up here in the positives. A little bit of negatives. 0's in it, so when we go to check 2, we can use 0 again. Okay, so here's check 1. I'm going to plug directly in. Now remember, for check 1, you actually use your number. We're testing our boundary point with an equal sign. So 4 times -1. So we're going to get -4 plus 10. And sure enough, -4 plus 10 is 6, and we're good. Check number 2. Pick a number in the solution set, so I'm going to pick 0. Plug it in with the inequality, so 4 times 0 plus 10. So 0 plus 10. And we get 10. So is this true? Is 6 less than 10? Yes, it is. Check is good. I know my answer is 100% correct. Okay, number 5. A little bit more going on here, but nothing we haven't seen before. Just have some simplifying to do, so I'm going to leave this side alone for a little bit. Let's go ahead and combine like terms. Okay, put those together. It's -3 and -7. That's -10. And then this, both positives, that's 205. Now I've got it in nice standard form. I'm going to isolate the variable, so I'm going to start by getting rid of this 205 by subtracting it. So I still have -10n on this side. And now I'm going to stop at this point. I can already see, look, this coefficient is negative. So I'm going to have to divide by a negative. So just thinking ahead, as soon as I see a coefficient to my variable that's negative, I start to remind myself, don't forget to flip this when you go and divide, because you're going to be dividing by a negative. All right, and then on this side, we're going to get -200. We're going to divide by -10. If you didn't divide by the negative would stay. So we want to get rid of it. But now that we've divided by negative, this has to flip the other way. So now it's going to be open this direction, still with n over here. 2 negatives make a positive, and that is 20. So n is less than or equal to 20. So we're reading it from the variable. If you like it the other way, notice that it's closed towards n. So if you rewrite it, make sure it's closed towards n. Either one of these are fine. We're going to graph it. Here's 0. Here's 20. It does have that equals, so it's going to be a filled in circle, and n is less than, so everything this direction. All right, check 1. Back to the original. Now you do need to go all the way back to the original, because if you simplified incorrectly, your check might work here, but it's not working in the first one, so you're not going to catch your mistake. So you actually do have to go back to the original, which I know seems like a pain because it'd be easier to just plug in right here. But again, if you simplified it incorrectly, your check isn't going to actually catch your mistake. So the whole point of the check is to catch your mistakes. Now we're plugging in our number, so -3 times 20 times 20. Okay, kind of a lot to do here. So I'm going to get -60, -140. All right. And at this point, it's all adding and subtracting. So I would check this right in the calculator, make sure it all works out. -60 plus 2 minus 140 plus 203 equals 5. That's what we were hoping. That's good. So now I'm going to squeeze check 2 in over here. 0 happens to fall in this again, so that's nice. Pick any number in the solution set. So you could have picked 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Any number less than 20. I'm going to pick 0 because it's in there. You could pick the negative number if you wanted to. But again, if 0 is in your solution set, it makes your life easy. Because, if you take a look right here, this becomes 0. This becomes 0. And you end up with 5. Less than or equal to, the zeros don't even matter. It's 2 and 203. That's 205. Is 5 less than 205? Of course it is. Okay, number 6, last one that we got to do these graphs and checks. Okay, so x is on the left side. I'm going to go ahead and add the 101 to get rid of it. Now this minus sign stays with this, and I notice, hey, I got a negative coefficient. I'm going to be dividing by a negative, so when I get there, don't forget to flip. And this is going to be 204. Divide by negative 102. Dividing by a negative means flip this the other way, so now it's going to be open towards my x. And I'm going to get a negative 2. So x is greater than negative 2. Here's 0. Here's negative 2. Open circle because there is no equal sign. It's open towards the x. That means greater than. So all of the solutions are greater than negative 2, which is all of these. So 0's in it again. So we can use 0 and check 2. Check 1. Equal sign plugging in negative 2. Okay, this I'm going to count as a negative times a negative, so it's going to become a positive 204. And when I put that together, that does equal 103. Check 1 is good. Okay, check 2. Back to the original with the inequality. Choose a number in your solution set. So not the negative 2, any number in the solution set, not your boundary point. So 0 is in it again. Let's use it. So I end up with negative 101 minus 0. Because of the multiplication, that's why I like 0. So basically negative 101 is less than 103. Yes, it is. Good to go. So I know that my greater than sign is pointed the right direction. All right, the next group that I have to do here is 8 through 13, but we're just solving the inequality. Okay, so it's just a matter of isolating the variable and then flipping the inequality if need be. No checks required for these, no graphs required, so just run in the numbers. All right, so just like if it was an equal sign, really the only difference is at the very end when you divide or multiply, just check if it's a negative. All right, we got some simplifying to do on the left side here. So negative 24x. This will be a negative 6 times 23. Okay, still not fully simplified. Here's my x, but then I have these two numbers. So I'm going to leave the negative 24x, but I'm going to put the negative 138 and the negative 73 together. So negative 138 minus 73. Now I've got it in that nice standard form, right? I've got the coefficient with the variable. I've got this single number over here, less than or equal to, or just less than 77. Okay, so I'm going to start by eliminating this number, your constant, leaving me negative 24x less than 77 plus 211 be 288. Now right here I notice, okay, I've got a negative coefficient. So I'm going to be dividing by a negative. And when I do that, I've got to flip this. So now it's pointing this direction. X is still there. And I get negative 12. Checking the answer key. I know this is correct. You could, of course, run a check if you wanted to. The directions do not ask us to, though, so we're just going to stop right there. Okay, number 9, dealing with some decimals and a fraction. Now, as soon as I see, okay, I got a bunch of decimals and a fraction, but this fraction is easy to convert to a decimal, I'm just doing it. 1/2 is 0.5. Just make your life easy. Not every fraction is going to convert nicely, but if you've got one like 1/2 that goes to 0.5 and you've got everything else as a decimal, let's just make it a decimal. This is already a nice standard form, no simplifying, so I'm going to minus 0.5. This goes away. As I bring this down, I notice I have a negative coefficient, so I start telling myself, don't forget to flip this when we get there. So 0.48 minus 0.5 is going to be negative 0.02. Now we are dividing by a negative to get rid of it, leaving me just y. This has to flip, and 0.02 divided by 0.2. Notice I didn't deal with the negatives. I can just do this in my head. Right? Why do I need to mess with the calculator? A negative and a negative is going to be a positive, and it's 0.1. So y is less than or equal to 0.1. Okay, not much to this one, just dealing with the fractional coefficient. So first we're going to minus the 12 to get that out of there. Always trying to isolate the variable. So 1/3 a comes down. Notice it's positive, so there won't be any flipping going on here. So to get rid of that, you're going to multiply by the reciprocal. You could also divide by 1/3. Plug it in your calculator, divide by 1/3. But multiplying by 3 over 1 is just multiplying by 3, so I don't even need a calculator. This is 9. 3 times 3. And now a is isolated, and for me, my handwriting is so bad, it looks like a 9 and a 9, so we got to be careful here. So if you want to flip this the other way, put the a up front. It's closed towards the a, so keep it closed. And a is less than or equal to 9. You can leave it the first way, though. Perfectly fine. Okay, 11. Notice that the d here is up top. You can always put it next to it if that confuses you. This is just a fractional coefficient, so when we go to get rid of this, we're just going to multiply by the reciprocal, negative 6 over 5. So no big deal. So minus 30, negative 5 over 6. D, now notice it's a negative, so when I do multiply by the reciprocal, it's going to be a negative, and that will flip this, so thinking ahead to that. That gives me 90, 120 minus 30. So now I'm going to multiply by the reciprocal, negative 6/5. Or, remember, you can always divide, because this is multiplication. You can divide by 5/6, negative 5/6, and that will work as well. You'll get the same answer. So these will eliminate, giving me D. This was a negative I was multiplying by, so this does have to flip. And so 90 times negative, bring up your fraction, 6 over 5. Negative 108. So D is greater than negative 108. Okay, number 12. Just some simplifying here. So when I simplify, I have to remember that this is a negative 5. I'm going to bring the 11 down and distribute. A negative and a positive is a negative, so I write minus 80. A negative times a negative is a positive, so I write plus. 7 times 5 is 35, and the variable tags along. Now, this side needs to be simplified even more. I have the 35p, but I need to put these together. 11 minus 80, negative 69. This was a positive 35, so plus. And now I'm in a nice standard form. So trying to isolate the variable, I'm going to start here. So I'm going to add 69 to both sides. I get 118 over here. This is gone. And everything's positive, so no flipping going on here. So P stays greater than or equal to. And I have a feeling that is not going to divide nicely. It is not. So what we should do is check to see if it simplifies. So I'm going to use my fraction button. 118 over 35. It does not. So that is fully simplified. We're going to leave it as a fraction. We're not going to round that nasty decimal off and change the value. We're just going to leave it as 118 over 35. All right, last one. Some big numbers, some simplifying, but nothing to be scared of here. right, so nothing's going to happen with this left side for a little bit. Let's go ahead and distribute here and distribute here. The minus 17 will drop down. So that's negative 2q. Negative and a negative is a positive 18. This is a positive 21. Positive times a negative is a negative 24. All right, start combining like terms. Got a q and a q. A negative 2 and a negative 24 is negative 26. And then 18, 21 minus 17. That is not right. What did I do? 18 plus 21 minus 17. There we go. Positive 22. All right, now I'm in standard form. Now I can actually start eliminating things. So a plus 22 is going to be minus. Goes away. As I bring this down, I notice that I have a negative coefficient, which I'll have to divide by, so I will have to flip this. Just thinking ahead as always. So now I'm going to divide by negative 26. Gives me q by itself. This has to flip. 572 divided by negative 26 is negative 22. It's open towards the q, so if I was reading this, I would say q is greater than negative 22. And if you prefer to flip it the other way, make sure it remains open towards the q and still says q is greater than.